Right. Now we'll say we are assigning a new name for that. For that we have to define the new one. So normally force is equal to mass into acceleration, ME. Look at this. When we are giving definitions for new units, or even we are defining another quantity, physical quantity in physics, except in two places, all the other places it is very easy. The reason is we consider always 1. 1 into 1 is 1. Correct? 1 into 1 is correct. So here you make it mass 1 kilogram. Here 1 ms minus 2. Then this is called 1 Newton. How to define now? A force required to. Required means needed. The force needed to move an object of 1 kilogram with an acceleration of 1 ms minus 2 is defined as 1 Newton. That is very easy for you to understand. Right? That is defined like that. So then I will use 1 Newton, 1 kilogram, 1 ms minus 2. Then write up to this. Finally, Newton is equal to kg ms minus 2. Both are the same. This is simply derived unit, which is equivalent to derived unit is unit. Come up to this. Then in words you write it. Definition, Newton. The force required to move 1 kilogram of an object. About the physics class, no? So I sent today I sent the link. Okay. Right. Yeah, the problem is where some students haven't seen this. Right. The force required to move 1 kilogram of object with an acceleration of 1 ms minus 2 is defined as Newton. Very simple. What is Newton? You have to consider about two things. One is 1 kilogram object, it should be moved or we push it with an acceleration of which one? 1 ms minus 2, then that is called 1 Newton needed force. Right. Next situation. Now, pressure. Pressure. For levels you have done pressure. Pressure is force divided by area. Force divided by area. Normal way, it is very simple. We consider this as force. Now 1 Newton. All 1. So this comes as 1 is equal to 1 divided by 1. 1 divided by 1 is 1. This is 1 Newton. This is 1 square meter. Area is measured using square meter. Then this is normally called 1 Newton per square meter. Then, right? So therefore, you can write it as 1 Newton, 1 square meter at once. Then answer is 1 Newton. Right up to this. This is equal to, this is how you are getting it. Now if you want, you can write like this. 1 Nm minus 2. This is given the name Pascal. Pascal is capital P. I have to tell you about those things now. This is how it comes. This is a normal way. But we are assigning another name for that. That is Pascal. How to define? A force of 1 Newton is exerted. Exerted means giving a force on an area of 1 square meter. This area is 1 square meter. Perpendicularly, that is needed. You can't have the force. If the body is there, you should have perpendicularly, not making any angles like that. Perpendicularly, then the pressure on this is defined as 1 Pascal or Pascal. Then right? When a force of 1 Newton, when a force of 1 Newton is exerted on an area of 1 square meter, 1 square meter perpendicularly. That is a must. You have to say perpendicularly. Then it is perpendicularly. Then the pressure is called a Pascal. That is 1 Pascal. Pascal is denoted by PA, capital P simple A. So then 1 P Pascal PA is equal to this. Right. Now we know that 1 Pascal is equal to 1 Newton per square meter. Here, then derived units, not simple derived units. Derived units are concerned, they give, derived units are concerned, for that we give a new name to respect the scientist, mainly physics scientist. What we do is, we give or we assign their name for those. Then right, for the derived units, normally assign a scientist name to respect them. Then we had to understand another one. So we had to do that for the respect them. Then those letters what we are using, just like writing a name. Then write the symbol for derived units given according to the way we write names in English. That means normally one letter is used, not down. Normally one letter is used. Right? Normally one letter is used. What is a letter? Normally one letter means Newton in. Then Newton in. This is a special case. This is a special case. Newton in. The other one, Pascal. I will explain this letter or the symbol later. Pascal. Then Pascal. Pascal capital P. But P is normally used in chemistry. N is also used. I will tell why it is N still. P, then it is phosphorus. Therefore, we go for the next letter, PA. But it should be simple. But in school, the teachers are saying when two letters are there, first one is capital, second one is simple. That is not to be told actually. The reason is that comes with how? How it comes? Because when we are writing the name in English, first letter is capital, second letter is simple. That's a normal way. There is no need to say first one is capital, second one is A. This is a normal way you write the name. But here, this is a different one. Right? Newton. But nitrogen is there. No? So therefore, we can't use it. Then Newton next letter is E. Then neon is there. Then we have to go for the next one. Then the scientist, that particular union decided that for Newton, we forget about everything because he is the first person when we consider about the physics. Then we assign only N because E is assigned that is new. Then Ne neon. So then N is nitrogen, E is new. We can't go for another one, right? So therefore, that is kept without changing, right? So remember, derived units always scientist name is there. That should be written according to the English name how we are writing. That is the method. Okay. Now we'll go to the next one. Next one, work done. Work done. Done. Work done is force into displacement. Displacement. Why I'm saying that displacement? The distance towards the same direction of the force. That means here you applied 5 newtons on this. One particular place it's here. After a certain time it is there. Then this displacement, how it travels towards the same direction as the force. Force is towards this direction. Displacement also measured to that. Therefore, it is a vector. Later I will say what is a vector. So then displacement. So therefore, force is Newton, displacement is meters. Then Newton meters. But we assign another one. This is called joule. That is called joule. So this should be then 1 Newton into 1 meter. The work done is 1 joule. That means 1 joule is equal to 1 Nm Nm. 1 Nm. Newton meter. Now, how to define then joule? When a force of 1 Newton is taken away or displaced by 1 meter, 1 meter to the direction of the force, then the work done is defined as 1 joule. First you write up to this. After that, definition. Then write a force of 1 Newton is moved. You can use the word displaced also. Moved a displacement of 1 meter to the direction of force. The work done is called 1 joule. Work done is called 1 joule. Joule is denoted by capital J. Capital J is not a problem, no? Joule is a scientist. So therefore, because J is not used in anywhere in the capital J, is not used anywhere in the physics or chemistry. Therefore, we keep it like that. So then 1 joule is equal to 1 Newton meter. Here, you know energy. When there is a work done, work is done, that work is always, it converts into energy. Or to do a work, we require an energy. So therefore, work done is equal to energy amount. Then right? To do a work, there should be an energy. There should be an energy. Energy. In other words, to do a work, in other words, the units of energy must be equal to units of work done. Units of work done. Then you write units of energy is all those SI. If you want, you can write SI. SI units of energy is 1 joule. I will explain another question. In MCQs, in the first unit, they are giving similar units. So then 1 joule or joule is equal to Nm Newton meter. But if you simplify this further, Newton is equal to kg m s minus 2. Earlier we got this one. Newton is this one. Now into m. So therefore, this is equal to kg, then m into m, powers are added, m squared, s minus 2. That is 1 joule. So therefore, our MCQs, equivalent 1 joule or joule, 1 joule is equal to 1 Newton meter. That is equal to 1 kilogram squared S minus 2. This is for the question. Then MCQ sometimes this answer and this is there, or this answer and this is there. But SI unit is this. Right, note it down. Before that we did one, that was Newton. 1 Newton was, we consider 1 kilogram, then 1 m s minus 2. After that we did Pascal. 1 Pascal is equal to Newton per square meter. This can be again considered as 1 Newton. 1 Newton is kg m s minus 2 into m minus 2. So m here 1. Base is the same. Then powers are to be added. 1 plus minus 2 means m1. 1 plus minus 2 is equal to minus 1. So therefore, kg m minus 1 s minus 2. Another way. For MCQs, they can give you as a question 1 Pascal is equal to 1 Newton per meter square is equal to 1 kg m minus 1 s minus 2. So then for MCQs, this type of relationship is given. Right. Now, any derived unit is concerned, that should be done in this way. Then we can get the new one. I explained up to Pascal. Then work done. Only another one is there. That is power. Power. Power is work done. Normally O level you said work only. Divided by time. Normally here we can write time or time taken. Taken means work done divided by time taken to do that work. So then work done is joule. So then 1 joule. 1 second. 1 divided by 1, answer is 1. Then power is called watts. Watt came with James Watt. Steam engine was invented by him. So therefore, watts capital W. Then 1 watt is equal to 1 joule per second. Right after that. Right. Now we'll come to next situation. Definition. Then write definition of watts. So that is what, then right definition, when when 1 joule of work is done in 1 second, a work of 1 joule is done in 1 second, then the power is defined as, then the power is defined as 1 watt. What normal name? WATT. So this is capital because it's a name. That is W we used. That also can be written in the other way. 1 watt is equal to 1 joule per second. So 1 joule is equal to, what is joule? Yeah. Newton, we wrote it early. Newton meter per second. Newton is, that can be written as 1 kilogram ms minus 2 ms minus 1. So therefore this is kg m into m squared, s minus 2 s minus 1 s minus 3. Then we can consider it as 1 watt in this way. So then 1 watt is equal to 1 Newton ms minus 1. Understood? So then after that, we can consider this again Newton 1 kg m square s minus 3. So for MCQ, sometimes these two will be given, or these two, or these two can be given. All three also can be given. So that's there. So then here, if you can't see 1 watt, 1 nms minus 2 is equal to 1 kg m squared is minus 3. So derived units, I told now. There are so many derived units under other sections. Very good, you know. Did you try today? No. But physically you would like to come. Well, because other area is good. So normally reception. Hello? I come to the normally it is good. On the deal. That classic. अरे भाई क्या है मम्मी बात Easy training because connection is also the students. Right. Now we'll consider next one now. Now derived units I explained, but there are some more derived units. We'll come to another one. That is now dimensions. Next one, dimensions. Dimensions. Normally, they are asking to write the dimensions. Give me 1 second because I'm calling another one because these students haven't given me proper numbers. My mother's numbers are there, their numbers are there. Different time, different numbers are sent. Right. Dimension means we are normally assigning a letter for each physical quantity. Like them. There are base or basic physical quantities, and to represent them, a letter is given. Within bracket, assigned. A letter is assigned. And that is called that basic physical quantities dimension. Dimension. That day I halfway explained it. First one is length. Dimension is capital L. So dimension capital L. Next one, mass or mass. Capital M. Dimension is M. Then time. Dimension is T. We had 7 basic units. Those 7 are concerned, we have 7 different dimensions. But the thing is, our syllabus is having only these 3. Then right, in our syllabus, dimensions are asked only for the first 3 base quantities. These are length, mass, these are length, mass, and time. And time. And time. Length, mass, time. The dimension of length is the first letter of the word in capital. That is capital L. For the others, for mass, capital M. For time, capital T. After that, you just write table, base, quantity. Only these three are there for us. Right. Now, use of or uses of dimension. Number one, uses of dimension heading. Number one, to derive the dimensions of or to obtain the dimensions of other physical quantities. Second one, to verify the correctness of a given equation. To verify the correctness of a given equation. Next one. To derive, third one, to derive an equation when relationships between relationship between relationship between the physical quantities are given. I will explain all. There is another one that is not needed now in the new for the new syllabus. That is called converting factor. If you want, you write to find the converting factor. Converting factor from one system of units to another one. One system of units to another one. I said last time three systems. British units, CGS units, and SI units. All those are concerned, then we can do that. Right. But here you put a question mark like that. Because you know that is not needed, but it can be used to do some MCQ CC. Directly that is not there in the syllabus. Now I'll consider the first one. To obtain the dimension of other physical quantities. Heading. Finding dimensions of other physical quantities. Finding of dimensions of other physical quantities. Number one. Here, that is the number one. Will other physical quantities, I'll check it, I'll tell you about it. Dimensions of will write one heading. First one, area. Oh, just write here. No, number one, area. Right? Normally, there is a certain thing you have to remember. Now, because old notations are there, new notations are there for this. Instead of writing these dimensions of area, we can write it like this. A is area, you put square bracket. That means dimensions of area. Then right? When you place a square bracket for the even area, you can say area, that means its dimension. So you can write it now. Area is equal to length into length. So dimension of area, initially we'll write like that. Later we are not writing the other step like this. Dimensions of length into dimension of length. What is the dimensions of length? Capital N into capital N. So this is L square. Dimensions of area. This is the way we are writing now. All notation here, there's a square bracket comes here. That is not accepted now. Next one. Dimensions of, in future you can get these things. In future means after few weeks. Some notes are on my YouTube channel. Not everything. So then after that it is easy for you. That means, but it is not, I'm doing a bit quickly there, but all the notes are not there because the class is just like more than 3 hours like that, no? At least 2 hours and 45 minutes is there. Normally, YouTube, one section is 1 hour or one maximum 1 hour and 20 minutes. Right. Now we'll go to next. Volume. So volume, second one, dimension, right? That is equal to length, the dimensions of volume. Then volume is equal to, what is volume? I'll write it there because you can't see. Volume is equal to, here, volume is equal to length into length into length. So volume is equal to that dimensions of volume is equal to dimensions of length, dimensions of length, dimensions of length. You are right, length here. So this is L into L into L. So dimensions of volume is L cube. Dimensions of, that is square bracket within, of volume is L cube. Fine. Next one, dimensions of speed. Dimensions of speed. Sometimes full question is given like this. Then speed, distance divided by time. Speed dimension is equal to dimension of distance divided by dimension of time. So dimension of speed is equal to, now I'll write it there, distance. Distance is L. Then time is T. So LT minus 1. So here you get dimensions of speed. Next one, velocity. Velocity is the same, just like the speed. But the thing is, in definition, velocity is defined as velocity is equal to displacement divided by time. Displacement divided by time. So displacement, then velocity dimension. You write velocity here. So dimensions of displacement, dimensions of time. Write those two words. Displacement L, time is T, then again LT minus 1. So then velocity dimension is this. Now next one. This is velocity. Then acceleration. Acceleration is change of velocity divided by time. Early one I use capital letters, but sometimes for the exam they are using capital T like that also in questions. Normally simple letter are to be written here, but if you can write the capital C for the word, it's not better. Right, so change of that. Now after second line, this is written by me according to a certain method. That method is the answer in method for the structured say question. Then acceleration. Then only we are writing change of velocity. Dimension is velocity dimension. LT minus 1 divided by T. So this is LT minus 2. So acceleration dimension is LT minus 2. Here, these steps are written according to the second paper answer. Second, structured essay or the other one is given. Structured essays, they directly ask, then we write this one and jump to this directly. Normally, second B part, essay question answer. This is essay. Right, next situation. Now acceleration, then after that we did force. Dimension of force. Dimension of force. Then force is equal to mass into acceleration. So mass is dimension of force, dimension of mass into dimension of acceleration. Write those two. Mass is m, acceleration is lt minus 2. Then force, dimensions of force is mlt minus 2. Right, next one, work done. Work done, that is force into displacement. Then dimensions of work done, you have write it there within the square brackets, write these two. Then force is dimension mlt minus 2. Dimensions of displacement L. So this is ml square t minus 2. That is dimension of work done. But remember, dimension of work done must be equal to dimensions of energy. Therefore, energy dimension also this. You have to write a statement after this. Dimensions of work done is equal. I'll read it. I'll dictate it. First come up to this. Right, next situation. Now we will come to the other one. Anybody wants to explain in a other language, Sinhala or like that, anything, tell me. Fine. Next one. When we come to work done is equal to energy. Then right? The dimensions of work done is equal to dimension of energy. So therefore, energy dimension is the same. Write the same thing. Right. Next one. After energy, I explain power. Dimensions of power. I'll directly write now. Is equal to dimension of work done divided by dimension of then time. Work done dimensions MLT minus 2, that is force, ML square T minus 2 divided by T, then ML square T minus 3. That is power. Yeah, can you tell me the early one? Energy. So dimensions of work done, force into displacement. We wrote it there. Force is ml t minus 2 into L ml square t minus 2. That is work done. Then power is work done divided by time. So work done is ml square t minus 2 divided by t, that is ml square t minus 3. Right. Now we have done up to that. Next one, there are some other quantities what we are using in future sections, mechanics, and that time we will explain. But another one I'll tell you, that is momentum. Momentum. Momentum means mass into velocity. Mass into velocity. So then momentum, dimensions of mass, dimensions of velocity. This is M, this is L, MLT minus 1. That is dimensions of momentum. So then, if you want SI units of momentum, this is SI units. So momentum is equal to mass into velocity. Mass is kilogram. Velocity is ms minus 1. So momentum SI units kg ms minus 1. This was not done under SI units because I wanted to discuss separately. Now, yeah, at the end of the class, who joined, please send me a message like that, something. Savindu, you have come, no? Yeah, this is being recorded, but new Zoom is concerned, there is another problem here. Now new Zoom app does not, what we record, it is not given directly. We have to automatically it converts even to the computer. It takes time. After the class, it will take normally 15 minutes for 3 hour class. Right. Well, last time what happened was I kept it here and when suddenly there was a disconnection of the current failure was there. Right. kgms minus 1. That is momentum. Now we'll come to, right? That is momentum kgms minus 1. Right. I'll come to another one. Then momentum, here I'm writing the same. Because for MCQs, they are asking questions related to the momentum. Units, SI unit kg ms minus 1. Now see what I am going to do. I can divide this by S and multiply by S. Nothing would happen. So these two cancel out. Divided by S, divided by multiplied by S. Just like divided by 10, multiplied by 10. Then 10 cancel. SS cancel. But these things together, I can write it as kg ms minus 2. S is taken now. Into S. kg ms minus 2 means, what do you mean by kg ms minus 2? kg ms minus 2 is Newton. So then here kg ms minus 2 s. Right? This is momentum. Momentum. Then this was taken as Newton. S. So another unit is Newton second. In MCQs it comes, which one of these would be the units of momentum? So then capital A, capital B, capital C like that. After that they will first answer A and B correct, B and C correct. Only A is correct, only B is correct, only all three correct. Like that, different things are there. So remember Newton seconds or kgms minus 1 momentum. Note down. Right, next one. Now we can get any SI unit or dimension. Dimension of pressure. Dimension of pressure. Pressure dimension. Directly we can write force divided by dimension of force divided by area. Force M L T minus 2. Area L square. Then M L T minus 2 L minus 2. This is 1. So 1 and minus 2 added. ML minus 1 T minus 2. Pressure dimension. Next situation. Now it is easy to find this. If you know the definition and the word equation, you can find dimension. Yeah. For 7 main base units, we have dimension. Actually, there should be 7, but for A levels, only 3 are to be considered. If they are going to ask, another one, not in the first 3, they give it, they say dimension of, right? Temperature is capital theta. Like that they will ask. Understood now? Anything other than this is given, that dimension is given to you. Special note. If any question, other physical quantity dimensions are to be used except length, mass, time. Then within brackets MLT, M comma T L comma L, MLT. That dimension is given to you. Example. Dimension of temperature is theta. This capital theta. Find the dimension of this was not done, but for O levels you have done. Dimensions of specific heat capacity. Specific heat capacity. Normally it is simple C. Some schools they teach as S. Then we are using the equation. I think you can read. There is an equation, but we have to do it later. But I'll just give an example. Q or H, heat is equal to MC theta. Theta is temperature. Now we want to get the value of this. Then MC theta is equal to H. C is equal to H divided by M theta. Now H is heat. Heat is energy, no? So then you have to write dimension of energy. Energy ml squared T minus 2. ml T minus T force into H. Then divided by again mass. H is energy. Energy is equal to which one? Work done. So then here energy that is equal to work done. Work done is ml squared T minus 2. Energy which is equivalent to work done. So work done divided by mass. Mass is capital M. Theta is given as capital theta. Cancels off. Then you are getting dimension of C. Dimensions of C is equal to heat capacity, specific heat capacity. L squared T minus 2. This theta is taken up. Theta minus 1. This is given. We don't want to remember. This is a given question also. Always, other than these three, they will give you the symbol for the or sign letter for the which one? The sign letter for the dimension. Right. Next one. I said to verify the next heading, to verify the correctness of a given equation. I'll write a certain equation. SC is equal to UT plus half AT square. Normally for all levels, this is not there. I think these days, some schools in Colombo, they teach. This is normally called linear equations or linear motion equation. S is displacement. Then U is initial velocity. Initial means initial velocity. whatever it is, a velocity. Then simple T is time. Simple A is acceleration. Then another one is there V, velocity, final velocity. Then five things are there. Displacement, this dimension, what is dimension? Displacement, L. Initial velocity, LT minus final velocity. You have to consider only velocity. LT minus 1. Acceleration, LT minus 2. Then you first write symbols and their physical quantity in linear motion equations or description of the letters. First you write like this. Displacement length. Initial velocity LT minus 1. Acceleration LT minus 2. Final one. That. Now dimensions of subtraction, same. Dimension of addition of the same physical quantity, same. Then write dimension of addition of same physical quantity has the same dimension. Then write difference, dimensions of difference of two same physical quantities is the same. That means dimension of change of velocity. Change of velocity. Change of velocity means change of velocity is equal to final velocity minus initial velocity. Final velocity minus initial velocity. Now, final velocity, anyhow this is velocity. This is velocity. So LT minus 1, here also LT minus 1. Never consider LT minus 1 minus LT minus, there's nothing zero. No. It's like this. These are, just keep like that. Here the difference is also the same, LT1. Different. Addition is concerned, also LT minus 1. Don't consider addition 1. Again LT minus 1. This is LT minus 1. Addition also the same. Note down this. This is LT minus 1. So can you see this red and blue colors properly? These colors can be identified. Black is okay. Can see, no? If you have a problem, put a message later with those two colors. Right. Next situation. I'll come to the next situation. That is because you don't know that some schools these equations were given. But I'll give you no S, what is U, what is T. Theory is this. Then write theory. Don't write, in an equation, we'll say S is equal to ut plus half a t square. All the terms are having the same dimension, then the equation is correct. This should be having the same as this one, as this one. Then you have to know about what are the terms. Terms means separated by equal sign plus or minus, not multiplication. Those are terms. Then these circle ones are terms. A separately T square not terms. So then F equals MA, we did this equation. So terms are F, MA together. Understood now? Those are terms. Then write terms of an equation can be identified easily or can easily. They are the ones separated by plus, comma, minus, comma, equal signs. Then only one equal sign, then only two. This is having how many terms? One term, two terms, three terms. 1, 2. Then V equals U plus 18, another one. How many terms are there? 3. Why? Separate in by equal sign and plus. 1 within equal sign, within plus, these two together. Or we can consider two corner ones and the other things. That is also easy method. Then how many terms are there? 1, 2, 3 terms. Then note it down. 3 terms, 2 terms, 3 terms. Right. Next situation. Right. Next one. Now we are going to prove. Then write question or example also you can consider for that. What is the example? Prove that the following equations are dimensionally, D-I-M-E-N-S-I-O-N-A-Y, dimensionally correct. First example, number 1. V equals U plus AT. Now I gave this now. V is final velocity. This is velocity. This is velocity. This is acceleration. This is time. Right? This is how we do. Answer is given as the second paper answer. Second paper answer. So then, first you write dimension of V. LT minus 1. Dimension of U. LT minus 1. Dimension of AT. Dimensions of A into dimensions of T. Square bracket means the meaning of that is dimension. Instead of writing dimension, we can put a square bracket. So acceleration dimension LT minus 2. Time T. Then these two are to be considered or added together. LT minus 1. Then dimensions of dimensions of all terms are the same. All the terms are the same. Therefore, given equation is dimensionally correct. You are right like that. So then theory is this. Then write theory. If you want, write it again. Theory. When the dimensions of dimensions of each term in an equation. Dimension of each term in an equation is the same, then the equation is dimensionally correct. Dimensionally correct. Right. Now we'll do like this. So, dimensions of what? Then example. Prove that the given equation, I gave it. So therefore, you can write the equation, do it. But I am giving this answer according to the second paper, B part. Second paper, part B. Part A is structured essays, part B is essays. Dimensions of all terms, I will dictate it or read it. Dimensions of all terms are the same. Therefore, the given equation is dimensionally correct. Here, sometimes in school they do like this. That is not accepted for the second paper. Now, some teachers are doing like this. U, LT minus 1. V, LT minus 1. A, LT minus 2. And again T, LT minus 1. Dimensionally correct. For the second paper answer, this is not to be the way you have to write. That is not accepted for the second paper. This is the second paper answer. Now I'll come to the next one. Complete it. Then I'll come to the next one. Next equation. Next equation. S is equal to ut plus half a t square, which I wrote earlier. So dimension of S is displacement L. Dimensions of ut, that is dimension u into dimensions of t. U is LT minus 1. This is t. Again L. Then dimensions of half a t square. Half is not having any dimension. So dimensions of a, dimensions of t, then square. Dimensions of a is LT minus 2. Acceleration. Then time t square. Therefore, LT minus 2t square plus 2 minus 2 cancel out. Then L. After that you have to write dimensions of all the terms are the same. Therefore, the given equation is dimensionally correct. That statement you have to write. If you want, I'll read it. Yeah, I'm doing the theory plus the question also. Normally, in the class, I do it. Otherwise, you are in trouble with, you have to do separately these things. 1 or 2 example can be given. But first month, I will do all. After that, you can do it, them as homework. Right. Now I'll come to the next one. Next example. This is understood, no? T square to the power 2 is t square. Then write here, all the terms are having the same dimension. All the terms are having the same dimensions. Therefore, the given equation is dimensionally correct. The given equation is dimensionally correct. Right. Now next example. V squared is equal to u squared plus 2as. Third example. Then dimensions of v squared, that is equal to LT minus 1 to the power by v squared. That means if you want, you can write like this also. Dimensions of v into dimensions of v squared. Then LT minus 1, L squared, t minus 2. Other method, you can directly write v squared. Then LT minus 1 to the power 2. Then what happen is, you mark here 1 Then here 1 into 2. This one minus 1 into 2. So then L square T minus 2. This is how the other method is concerned. Then you get dimension of B square. Then dimensions of U square, dimensions of U into dimensions of U, same no? So directly write L square T minus 2. There is no need to show it again. Because they know, when these are the same no, they give the marks only for this. Then after that, dimensions of 2A's. 2 is not needed. Dimensions of A into dimensions of X. A is LT minus 2 into L. Then L squared T minus 2. Then see L squared T minus 2, L squared. Dimensions of all terms are the same. Therefore, given equation is dimensionally correct. Not done. Other one. I will send you some questions by tomorrow. Hello? What you left? Ah. Connection poor ne? අර ළමයි දෙන්නෙක් මේ දාලා තියෙනවා කනෙක්ෂන් නැහැ කියලා ඒක. මම දන්නේ මේ නෑ මේ ළඟත් මේ කොතන මෙතන කලමුල්ලෙත් නැහැ සමහර දෙන්න. ඕ මම ක්ලාස් එකේ ඉන්නේ ආට කනෙක්ට් වෙන්න බැයිද දැන්? මේක රෙකෝඩින් එක තියෙනවා. දැන් මෙහෙමයි මම ෆිසිකල් එක අරගෙන පටන් ගන්නවා එන එතකොට ආට එන්න පුළුවන්. මම මේකෙන් අයින් වෙනවා එතකොට එන්නකො. මම දාන්න ඩබල් සුමනේ අපි කතා කරලා දාමු. Right, next one. So all are having connection problem. This boy is also having that. Then you can hear properly, no? If there is any problem is there, send me a message because I can do it because I have 3 on this. I have 3 different routers. So 2 dialog and SLT line is there on the other one. We can really get that also. Then it will be all right. Any problem is there, tell me. Send me a message today. Right. Now we'll consider another equation. That equation S is equal to U plus V divided by 2 into T. Now it seems to be very different. Now terms you can't see. This 2 is common. S is equal to U into T divided by 2 plus V into T divided by 2. Now we have 3 terms. You have to simplify. ut divided by 2, vt divided by 2. Then you have to write dimensions of S L. Dimensions of ut divided by 2. 2 we do not consider. Dimensions of u into dimensions of t. LT minus 1 t. That is L. Vt over 2, there is no need to check because u is velocity, v is velocity. Same story, u, vt, then it is LT minus t, again L. So all terms are having the same dimension. Therefore, this given equation is dimensionally correct. Given equation is dimensionally correct. Right, now we'll come to another equation. F equals MA. We did it, use it. This is force. Dimension of F. This is force, no? You remember, this is force, this is mass, this is acceleration. So therefore force M L T minus 2. We did it. Remember that. Dimensions of M. That is, sorry, dimensions of 2 terms. M A. M into A. That is capital M L T minus 2. This is L T. This is LT minus 2. Then you get again MLT minus 2. So both are having the same dimension. Therefore, it is dimensionally correct. But there is another easy method. I will teach after this. Normally, two terms are there. We are using that method. First, you do this one. All those sections you can see from the YouTube after another week. This weekend also you can see, because we have uploaded and taken away those, because we are changing some videos front sides. Okay, now we'll come to the other second method. Then right, when the equation has two terms, not it. Now, when the equation has two terms, there is another method to prove it. There is another method to prove it. That is, yeah, we'll see what it is. There's another method. Left hand side and right hand side story. F is equal to MA. This is left hand side, LHS. This is right hand side, RHS. Then this is simple brackets. Dimensions of left hand side. Then first you write left hand side is F. Dimensions of left hand side. That means dimensions of F. That is equal to MLT minus 2. Then right hand side, MA. Dimensions of right hand side. Dimensions of M into dimensions of A. That is MLT minus 2. Both are same. No? Dimensions of left hand side is equal to dimensions of right hand side. Therefore, the equation is what? Equation is dimensionally correct. Dimensionally correct. Yeah, after the class, please send me some comment saying that I want to know about the board clearance with the color. Board clearance with the color. That is black, okay. So you can write black, okay. Red, problem is there. Don't say problem. P is enough. Then for the other color, I'm using sometimes blue, blue. If it is okay, okay. Otherwise, problem. And sound. Clear or unclear. Clear or unclear. Second one, picture. Clear or unclear. Unclear means blurred. Those things please send me, because we can correct those things using the different internet. Today I'm using a different one. That day I use a dialog one. Today also dialog different one. So we want to check the better one. Here, this is the method. The equation is dimensionally correct. You don't know how to write correct? Right hand side, left hand side soul. I will try to send today the equation question papers. No, not today, tomorrow. Right, next situation. Pressure is equal to force divided by area. This is area, this is force, this is pressure. How to do that? Pressure is equal to force divided by area. Now, we have to get first one is dimension, left hand side. Left hand side is P, pressure. Left hand side dimension, dimension of P. That is, if you can remember, do it. If you can't remember, you just write it, separate P is equal to F over A. That is not needed here. Force is ml T minus 2 divided by area is L square. Then ml minus 1 T minus 2. If you don't know, you can do it there. And here you write directly ml minus 1 T minus 2. Then right hand side, F over A. Right hand side dimension. Dimension of square bracket F divided by dimensions of A. So then dimensions of F. F is M L T minus 2 divided by L square. So this is equal to ml minus 1 t minus 2. Then dimensions of left hand side is equal to dimensions of right hand side after that. Therefore, the equation is dimensionally correct. From next week, I'll be sending 5 minutes or 6 minutes early the link. Quickly join. Any problem is there, send me a WhatsApp message. If you do not like to call me, send me a message. Okay. Now we'll come to so this type of equations are lot in our syllabus, but not in mechanics. Other sections. Then you have to know their dimensions, each and everything. According to that, you can. So when I send now I'll tell about the questions I'm sending. Unwanted ones are what you don't know are there. So I will send the equations like this. We'll say velocity gradient. So this is in the 10th unit, gradient. There I write it as velocity difference divided by length. Then you can find it easily because velocity gradient dimension is equal to dimensions of velocity difference, dimensions of length. Velocity difference is velocity, LT minus 1 divided by L. Then answer is T minus 1. Like that, right? Example, velocity gradient is velocity difference if you have any problem with the writing method, tell me, then I'll write more clear. Spelling must be no. We know that you know the velocity, this is CITY, difference divided by length. Find the dimensions of velocity gradient. Then write, this is how. Then after that you write again velocity gradient dimension. Dimension is curve. Velocity difference. Sometimes we write diff only. Difference divided by time. Sorry, length. So then dimensions of length L, velocity difference L T minus 1, L cancel out T minus 1. Right? Like that I'll give you. Right. Next day we are doing deriving of equations. using the what? Relationships. Go through this. If you can go through today itself, it's better. If any problem is there, let me know. If you have any problem with the clear of the board, the color I'm using, and clear voice is clear, then the other one is picture is clear, video. Clear means the color, not the other. Distortions are coming only, tell me. Square ones are coming. That is normally called pixels or squares. Pixels problem of this is there. Right. Good night for everybody. Please go through everything. I'll send needed notes and the questions I'll send tomorrow, by tomorrow. Okay, good night.